Good evening, everyone. My name is Jack McPherson. Today we'll be going over flight planning and the importance of it. So we're going to start off with how to get your appropriate heading. So as you know, the heading is the direction of flight you'll be going in comparison to magnetic north. And so the first thing you're going to have is going to be your true course. This is the direction of flight as measured on a chart clockwise from north. So obviously due north is 360. East is 090, south is 180, and west is 270. Next thing you're going to have is their true heading. So this is simply true course when, with respect to your wind correction angle. So obviously when we are up in the air flying, we are going to have wind with both speed and direction. That will push us off course, and so we need to compensate for that, and we do that with the true heading. Next thing we're going to have is our magnetic course. So this is simply our true course compensated for the variation between magnetic north and true north. And so the difference between that you will have on your VFR chart as your isogonic lines. And so here in Murfreesboro it is around 4 degrees to the west, meaning we have to add 4 degrees to our true heading. Your magnetic heading is next, and that is simply your magnetic course, again corrected for wind. And so this will be your final heading that you need and will allow you to get from point A to point B with both wind and magnetic course compensated for. Next thing we're going to go over is going to be the altitudes. The first one you're going to have is your indicated altitude. This is the altitude read directly from your altimeter indicator with the current pressure setting inputted. As we know, the standard pressure is going to be 29.92 inches of mercury or 1013.4 inches of millibars. And so obviously that will be different around, and so you may need to add or subtract your altitude to compensate for that. That is going to be more covered in pressure altitude, which is the height above the standard datum plane of 29.92. We get this by simply multiplying the difference between the current pressure setting and the standard pressure setting of 29.92 by 1,000, and then adding that to the field elevation where we're at. So you would add that number to, in our case, 614 at Murfreesboro, and you get your pressure altitude. Your density altitude is, again, pressure altitude, just this time corrected for non-standard temperature. As we know, standard temperature is 15 degrees Celsius or 59 degrees Fahrenheit. Here in Murfreesboro, it's usually much colder or much warmer than that, and so we have to correct for that. And we do that with density altitude. We do that by taking the degree in Celsius, so let's say 15 degrees Celsius minus 15 degrees Celsius, multiply that by 120, and then add that to the pressure altitude. The last two altitudes we're going to talk about is going to be true altitude, and that is the true vertical distance above sea level, and then absolute altitude, and that is the true height above the ground, also represented in AGL. And so we're now going to go on to airspeed. The first thing you're going to see is indicated airspeed. That is going to be the airspeed directly read off the airspeed indicator. You would next have calibrated airspeed. This is simply indicated airspeed corrected for installation and instrument errors. Next you have true airspeed. True airspeed is the airspeed at which the aircraft is moving relative to the surrounding air, and this will be affected by, this is going to be affected by wind and temperature and such. And then finally you have ground speed, and this is the speed of the aircraft in relation to the ground. So many times your true airspeed may be more or less than your ground speed due to the wind conditions that you are flying in right now. Next, we're going to go over pilotage and dead reckoning. These are the two forms of flight planning. And so pilotage is simply navigation by reference of landmarks and checkpoints. And so you'll pick a couple of checkpoints between the two airports you're flying, and use those to make sure you're on the correct path. When picking these checkpoints, it's very important to make them obvious to the eye and not difficult to find. So I use airports or towns or lakes, and so these are easy for us to find while we're in the air and are pretty distinguishable from common land. You don't want to use small roads or fields because those can be mixed up very easily and you can get lost. The other form is dead reckoning. So this is navigation solely by calculating your winds, your time, your airspeed, your distance, and directions. And so you use both, again, this VFR plotter and your E6B flight computer to do that. And on the front of the E6B, you can calculate fuel flow, airspeed, and such. And then on the back, you can calculate your ground speed and your wind correction angle that we mentioned earlier. And so at MTSU, we use both dead reckoning and pilotage together in order to give each other kind of a backup. And they're really important to know. They both have their pros and cons, but I would highly recommend using them together. The next thing we're going to do is going to be the weather check. So obviously all of us going for our CFI have our instrument rating, but we're going to let this be private pilot, so we need to fly in VFR conditions. You can get a weather briefing from either ForeFlight, aviationweather.gov, or you can call 1-800-WEATHER-BRIEF, and they can give you a very detailed briefing on the current conditions and what it may be at your destination. This is very important because we want to stay legal, but more importantly, we also want to stay safe. You want to avoid thunderstorms or clouds or any sort of hazardous weather that may negatively affect you. And so you need to have both legal minimums and personal minimums. So obviously you need to meet the legal minimums for the airspace you're flying in and out of and into, and you also need to have personal minimums. So just because it is legally allowed to fly doesn't mean you as a pilot may be comfortable to fly, and so you need to have that no-go decision in order to be a safe pilot. So me, in my personal case, I use the I'm Safe checklist, the 5 Ps, PAVE, and various other kind of checks to make sure that I and the plane are ready to go for a safe flight. And so it's really important to use that, because if you don't feel comfortable flying, or if you don't feel safe, then it may result into pretty bad scenarios. The next thing we're going to go over is going to be your GPS navigation. So I mentioned earlier we have pilotage and dead reckoning, which are both great sources of getting from point A to point B, which we do. We also now, with technology, have GPS, which is a global positioning system, and we use that to navigate. That does a lot of the hard work and calculations for us, and gives us simply a line from point A to point B that has all the wind and magnetic deviation variation calculated for. And so it's really cool to use. You'll use it a lot in instrument and some in private, but it's a really cool tool to use, and can be used really if you ever get lost, as it can give you a kind of an idea of where you are and idea of where the closest airport is, so you can land safely. As I mentioned earlier, we have that flight plan that we have made, and so we need to file that flight plan. You can do it VFR. Not many people do it because it's normally very complicated and very hard to do. And so you can either do flight following, which you can request from ATC in the air, and the controller can give it to you, or he can deny it depending on his workload. But normally they give it to you, and this just allows them to give you traffic advisories and traffic separation, and allow them to have you on their radar to make it easier for them. You also have, obviously, for the IFR flight plans, an instrument you'll do this, and you'll talk about those more, but you can file IFR where ATC does a lot of the hard work for you and guides you in. And so the last thing we're going to talk about is diversion procedures. So if you ever have to divert due to weather, or due to maybe a mechanical failure or something else, diversion is really important. And so for us VFR pilots, you want to have a good idea of your surroundings at all times, whether you're on the ground or in the air, or in between two airports, where it may be. So you want to know where the closest airport is, maybe what the local ATC frequency is, or a local advisory frequency. You want to be able to do all of this so that in case you ever have to divert and get off your flight plan, you know where to go and how to land safely. And so it's really important to have that. And so today in our flight planning lesson, we've covered all of the altitudes, all of the headings, and all the speeds, pilotage and dead reckoning, GPS navigation, how to file a flight plan, weather briefing, and diversion procedures. If you have any questions, please feel free to contact me. And thanks, guys. Have a good night.